Eigenvector centrality. Eigenvector centrality is a measure of nodes' influence in a network, considering not just the number of connection but also the importance of the nodes it is connected to. Basically, it assigns the relative scores to all the nodes in the network based on the principle that connections to high scoring nodes contribute more to the node score. Now we'll see an example based on eigenvector centrality. So basically this is a graph given to you. Based on this graph, we will find out its eigenvector centrality. So total number of nodes we have is 1, 2, 3, 4 and 5. So we will be having a 5 by 5 matrix. So in the first iteration, we will write firstly the adjacency matrix. These are the nodes A, B, C, D, E horizontally as well as vertically, and check out this how to find out adjacency matrix over here. These are your nodes A, B, C, D, E. Now find out firstly whether you have a node from A to A. No, we do not have any node, so the value assigned is 0. Then check for A to B. Yes, we have a single node, so the value assigned is 1. Again, A to C, we do not have any node, so the value assigned is 0. Similarly, A to D, A to E, and so on. In this way, we have written a complete adjacency matrix based on nodes and their ages. Then multiply this adjacency matrix by a unity matrix. After matrix multiplication, we get these values. In short, for the first iteration, all these values are nothing but the degree of your graph. For node A, we have degree 1. For node B, we have degree 2. So we have one edge passing to A, one edge passing to D. So we have a degree of B as 2. It is 2 over here. Now, once we get this, we are supposed to find out the normalized value with the help of Frobenius norm, which is equal to square root of summation of Aij bracket square. So what we'll be doing, we'll be finding out its square. Then we will have a summation of this 1 square plus 2 square plus 2 square plus 3 square plus 2 square. Summation of this and then find out the square root of it. The answer comes out to be 4.69. Once we get this normalized value, we will divide each and every value with this value. 1 divided by 4.69, it comes out to be 0.213. 2 divided by 4.69, 0.426, and similarly. So we get this matrix for the iteration 1. Now find out the iteration 2. We are supposed to continue this iteration unless and until we get the normalized value same for 2 consecutive iterations. Now again, this is our adjacency matrix. Now instead of unity matrix, we will be multiplying this with the values which we have received in the first iteration. Now again perform a matrix multiplication over here. Once you perform matrix multiplication, you get these values. Again square all these values, take a summation of these values and then find out its square root. You will be getting a normalized value as 2.19. Now divide each and every value with 2.19. You will be getting this value. This is your matrix for iteration 2. Now this matrix will be using for iteration 3. Again, this is your adjacency matrix. Multiply it with this matrix. You will be getting this matrix. Square it, add it and find out its square root. You will be getting the normalized value as 2.21. Again, divide all these values with a normalized value. Again, if you see for iteration 2 and iteration 3, the values do not repeat. So you need to go further, that is for iteration 4. For iteration 4, this is our adjacency matrix. These are the values obtained in the third iteration. Once you perform matrix multiplication, this is our new matrix. We get the normalized value as 2.21. Now yes, in iteration 3, we have received the value of normalized value as 2.21 and iteration 4 also normalized value is 2.24. So the algorithm converges over here. So your final eigenvector centrality is whatever matrix you have obtained over here in the iteration 3, that will be your eigenvector centrality. Since the values of normalized value repeats for 2 consecutive iterations, we will stop over here. We won't be finding out further matrix over here. So this is our eigenvector centrality, the value which we have obtained in the previous iteration. For practice, you can consider this graph and you can find out its eigenvector centrality. I'll be giving you the answer also. We get an eigenvector centrality as this matrix after 7 iterations.